Okay, welcome to the afternoon session. We start with a couple of shorter talks. We first have Mr. Mohan Allam from Andhra Pradesh, from the Sri Vishnu Engineering College, Pune, and he's going to be talking about a system that they are proposing to implement using Raspberry Pi and Python to monitor aqua monitoring, basically to look at fisheries and things like that. So, welcome.
This is Kadur. Good afternoon, one and all. I am Mohan, and now my presentation is on Aqua Monitoring System using Python. Have a look on outline. First, we'll go for introduction. Next, the need of water quality monitoring. Next, implementation of the system. The final one is the mobile application. I think all of you know very well what are these things. Suppose if see in India we have the large coastal area. There we are having the shrimp culture is very high. In particular, suppose if see here Andhra Pradesh. Present we are I am in Andhra Pradesh. We are having farmers they are growing shrimp in a large manner. That's why actually they are facing so many troubles for this shrimp culture. That's why we are focusing on this system. First, we will see what is the need of this. What is the need of the water quality monitoring for the shrimp culture? Suppose if you see here, the success or the failure of the aquaculture purely depends upon the quality of the water. Suppose you see here, the water quality parameters mean the respiration, feeding, metabolism, and reproduction of the shrimps. And the farmer has to measure, he has to log means he has to store, and he has to monitor always from the starting to the ending of the crop. Crop means the starting to ending of the shrimp growing. And coming to the parameters which we are going to measure for the water quality are the pH of the water, temperature, dissolved oxygen, hardness, ammonia, nitrate. All are these are the main parameters which we have to measure for the water. And these are the optimal values. We have to see always whether the parameters are within the range of these or not. Suppose if you take temperature, it should be minimum is 26 and 33 like that. Okay, the remaining parameters are these are the optimal values which we have to which the farmers has to maintain for the good aquaculture. Actually, what is going on outside? In general, the farmers they will take the water samples from the pond, and they have to visit the labs nearby the city or the village, and there the lab they will test the samples, and they have to tell the results. Actually, it will take so much time, and every time they have to visit, it is very so expensive, and it will take much time. And that's why we have to go for the automation. Why don't we go for automation which will reduce all these burdens for the farmers? And now we will see the implementation. First, we will start with the architecture. So here we have the just starting from the left, we are having all the sensors like temperature, nitrate, dissolved oxygen, pH. All the sensors are connected to the Raspberry Pi. I will tell you later what is Raspberry Pi. I think many of you know very well about the Raspberry Pi. And these are the various ways how we can interact with the Raspberry Pi and send the data to the mobile. Okay, one by one I will explain. And it is one more diagram. The above all are the sensors for measuring all the parameters of the water. Actually, all are mounted to the boats under the water to measure the quality of the water. And the second level we have the cloud. There are the database servers where after getting let me explain the first diagram. Okay, first of all, it is a Raspberry Pi. Here it is a single board computer which can have a processor for computing and GPIO pins for adding attaching the sensors, and SD card slot for installing the operating system like Raspbian or Ubuntu like that. And the next one is the Ethernet port for connecting the cable, internet cable, USB ports for connecting keyboard, a mouse, HDMI port for connecting the monitor, and 3.5 mm jack for audio. is a simple single board computer, we can call it as. And is a flowchart which we are going to implement for the proposal. First, we have to start with we have to initialize all the parameters to the 0, all the temperature, dissolved oxygen, all to the 0. And first, we have to read the temperature. We have to get the data from the temperature sensor, and we have to, after getting the data, we have to compare whether it is within the optimal range or not. After that, we have to go one by one for each sensor, and we have to get the data. And finally, if all are good, then the pond is okay. And if any one of the parameters is not within the optimal range, then we can say it is the pond is in the risk. So immediately we can go for okay. We will see one by one. Actually, I started the project with three levels of the implementation: the first phase, second phase, third phase. In the first phase, we have to acquire the data from the sensors and send the data to the mobile app of the farmer. And second one is the capturing the images from the shrimp pond and send them to the user. A third one is okay. In the second level, the farmer has to identify whether the shrimps they get diseased or not. But in the third phase, okay, after getting the images, we have to make a machine such that we have to the system has to identify whether the shrimp is diseased or not, and immediately it has to send an alert message to the farmer. It is the third phase. Of course, presently I am in the first phase of the implementation, working with the sensors. In the first phase, simply getting working with the sensors, getting the data and send them to the mobile app. Actually, it is a setup for the project. Now we will see the Python coding. Actually, here where I am using the Python is after connecting the sensors to the Raspberry Pi. Here I have to access the data. That means I have to go for the GPIO programming. Suppose if you see here. There we can find some pins are there. Through that pins we have to connect the sensors and we can access the data through the pins only. For that I have to go for the GPIO programming. After that I have to send Suppose if you see this picture, we are having 4 sensors which are connected to the Raspberry board. For that I have to use the GPIO programming. After getting the data values into the board memory, now I have to I have to make a communication with the mobile app. So for that I have to do the socket programming. So socket programming means we are having some system calls like socket, bind, listen, send, receive. These are the primary system calls which we have to implement. So in the Raspberry board, I am going to use it as the server. There I have to implement the server-side programming code in the Python coding. And in the mobile app, I have to implement the client-side programming in the Android. Now you see the Python. In this slide, we will see the import statements for the different import socket, import SPIS, import OS. These are the various packages which we have to import into our Raspberry board to access the GPIO pins. And the next one is how to implement the socket programming. Simply we can see there s equal to socket dot, it is a socket creation, and after that we are having, we have to bind the socket with the port number and the host IP address, and after that we have to make the board listen to the client request. So we have to call the listen, and once if you have a request from any one of the mobile client, then it will send the data. It will send the data to a particular client, and it will have some receive system call also there. Actually, it is the sample code only. Now it is another way of implementation. In the previous case, only directly I have the communication from the mobile to the Raspberry board, but here I am taking the help of a cloud for the storing the data. Suppose if you see there, there is a communication path between the Raspberry board and cloud servers are there, and from the cloud servers to the mobile we have the communication. So now here I am using the Python for the communication between the Raspberry board and the cloud server. Here in my project I am using the parse is one of the cloud providing free service cloud. For that, in order to access that parse cloud, we have parse Pi, and it is a sample code which we can use in the Python editor to get the to work with the parse. And it is a sample data logging in a cloud. In the cloud, we are having tables where we can store the sensors data. From these tables on the cloud, we can access the data into the mobile by using the Android implementation. And suppose if you see here, is a mobile application. Here we can log in, we can provide the farmer with a sign in, registration. And as usual, we know all of you, registration is there, login. And in the home screen, we can see there the water quality meter, sample images, and application settings are there. Suppose if you press the water quality meter, then we will get the primary parameters of the water. That is the pH, temperature, ammonia, dissolved oxygen. And suppose if you press the pH value, we are providing the farmer with the current value in the green highlighted area. That is the current value. He will get the live data. And we can also get the data from the previous hours or previous days by providing the features within the mobile app itself. And temperature is also there. So in this way, we can provide all the templates. Now in the phase 2, here I am mainly concentrating on getting the images of the shrimps. It is the main phase where we can mainly concentrating on getting the images of the shrimps under the water and make them available to the user. So it is a simple code for capturing the images. Here we are getting we can use the packages pic camera. By importing that package into the board, we can simply we have to connect the camera to the Raspberry board, and we have to write the code by importing the pic camera like that, and simply we can capture by using this sample code. And here we are providing sample images. After if the farmer simply clicks the help shrimps, he will get all the shrimps. Maybe they may be healthy or may not be. And in the third phase of the implementation, here we are avoiding simply we are avoiding the farmer. That means actually in the second phase, the farmer has to take the decision whether the shrimps are get diseased or not. But now in the third phase, we have to make that, we have to learn the system so that the system itself identify whether the shrimps are get diseased or not. If any one of the shrimp get diseased, then immediately the information will be sent to the farmer. Then he will take the further action. Actually, why we have to go for here? The time is very, very important. It is the time constraint is very important. Suppose if any one of the shrimp get diseased in the water in the pond, immediately it will affect the entire pond, maybe within hours or maybe within days. So it will give the much result for the farmer. And here, if you see here, shrimps, we can get the images into the camera. Now we have to remove the noise, and we can use some filters and background segmentation, and we have to extract the features of the shrimp, and we can detect some diseased shrimps. Actually, the shrimps they will have some black spot or white spot diseases. So we have to identify those diseases. And suppose if you see here the diseased shrimps, like we are having the above one is the yellow spot diseased shrimp, and the below one is the white spot. Just I want to conclude that it will give more results to the farmers because they will invest lakhs of money on the ponds. And we will work. We are trying to. I will try my level best for the second phase and third phase. I need more help from professors like us. Thank you very much and thanks for providing this opportunity. Any queries?
Any questions? Next speaker, can you please set up?
Hello. Yeah. Hi. In your phase 2, you're taking images of the prawns, right? Sorry, the shrimps. How exactly are you taking the images? Where is the camera?
Actually, the sensors as well as the camera mounted to the boat under the water.
Mm-hmm.
Whenever the boat is moving, or maybe it may be still it is in the it may be in the water. Whenever actually I am going to use some detection algorithms, or I may use some sensors for getting the shrimp images. Suppose if we can arrange a sensor, whenever the prawn reaches to whenever it reaches near to the camera, then automatically the camera will capture the image and it will send to the board. Otherwise, we can also go for the frame difference concept also. Simply, it will capture one image and it will another image. It will find out the difference. If there, then immediately it is there is something is there like a strip, and it will send the image to the board.
Also, like in the water, the boat is also moving, and the shrimps also move at quite high speed. So you may need to adjust for that, I guess.
Boat is moving is okay. Maybe first we have to go for still. Boat is in the still position only. It may not be in the moving position. Thanks for asking the question.
Hello. Just wanted to know, like you said, you have communicating with a mobile device. So, like you have not connected the GSM devices or other stuffs to connect to the cloud, and so how it is possible? Like
yes, here we can for the Raspberry Pi board we can attach the Wi-Fi dongle. Actually, we are having USB ports. Through that, we can connect the internet dongles.
okay,
Directly,
like,
they can interact with the cloud.
fine.
We are developing some socket programming is there for that communication. Thank you.